Hello everyone, my name is Rekford Bong.
And my name is Falinah Misol.
Today we will present a study entitled Statistical Analysis on the Behavior and Strength of Cold-Form Steel Hybrid Connection. Introduction. The increase in recent research and the diversity of commercial application dealing with the use of cold-form steel structures in the construction industry was initiated at the end of the 1990s with the introduction of a roofing steel frame system for residential buildings. Nowadays, the C, Z, and I section of cold-form steel are commonly used for home, roofing, wall frames, railing, purlin, and cladding. In construction projects where cold-form steel is used, fasteners such as bolt and nut are commonly used. Other commonly utilized fasteners are self-driveling screws, which are used to make connection to metal cladding roof, as well as specialty roof such as framing members. Adhesive joints are also used in various industries because of their advantages over mechanical fasteners, such as riveting, welding, and bolting. A new connection method on cold-form steel that combines self-drilling screw and adhesive for cold-form steel connection or hybrid connection potentially offer an increase in connection strength. The application of hybrid connection is a growing area of interest among researchers. Nevertheless, limited studies have been conducted on utilizing combined adhesive with self-drilling screw hybrid. An improved understanding of the behavior of hybrid connection could lead to effectiveness of connection design. Thus, the aim of this study is to investigate the performance and behavior of hybrid connection. Problem statement. Self-drilling screw connection flow in cold-form steel structures could lead to weaknesses in the connection area, thus reducing the load-bearing capacity of the structure. The combined effect of element weakness and connection weakness on the cold-form steel structure often lead to a premature collapse of the structure. To avoid such damaging outcome, a new connection method on cold-form steel that combines self-drilling screw and adhesive for cold-form steel connection or hybrid connection potentially offer an increase in connection strength. Thus, a statistical analysis in cold-form steel hybrid connection strength are the focus of this study. To address the problem statement discussed previously, the following research objectives were outlined. Number 1. To determine the relationship between the number of screws and connection strength. Number 2. To determine the influence of using different plate thicknesses on connection strength.
This research is in the form of quantitative research. For the data collection, data was obtained from the experimental data from the shared test, and the data was analyzed using statistical analysis ICIRSST version 26. 36 specimens used in this study were single lap joints with varied number of screw and 80 mm of lapping length. All specimens were tested under tensile loading and collected test data were analyzed. The number of screws varied between 2, 3, and 4 screws. Plate thickness varied from 0.75, 1.0, and 1.20 mm, and the bonded length is 80 mm with adhesive thickness of 0.5 mm. The code of specimen for hybrid connection are as shown below. To get the answer for objective number 1, which is to determine the relationship between the number of screws and connection strength, a Pearson correlation test was conducted with 2 hypotheses. The null hypothesis: there is no significant relationship between the number of screw and connection strength, and the alternative hypothesis: there is a significant relationship between the number of screws and connection strength. To get the answer for objective number 2, which is to determine the influence of using different plate thicknesses on connection strength, a t-test was conducted. The null hypothesis is there is no significant difference in the connection strength between two different plate thicknesses, and the alternative hypothesis, there is a significant difference in the connection strength between two different plate thicknesses. These are the results from this research. For the Pearson correlation test, the significant value for all specimens is less than 0.05 of the significance level. Hence, the null hypothesis is rejected and the alternative hypothesis is accepted. For the conclusions, a statistically significant correlation exists between the number of screws and connection strength for flat section of cold-formed steels. Increases in the number of screws were correlated with increases in connection strength. For the t-test result, the significant value for all specimens is more than 0.05 of the significance level. Hence, the null hypothesis is accepted and the alternative hypothesis is rejected. For the conclusions, there was no significant difference in connection strength exists between two different plate thicknesses. The plate thickness does not influence the connection strength for flat section of cold-formed steel.
In this research, the effect of number of screw and plate thickness in connection strength were discussed. A significant correlation exists between the number of screw and connection strength in hybrid connection. According to Liu, Abdul Hamid, and Harshad, an increase in the number of screw correlate with an increase in connection strength. Experimental data shows that the specimen with higher plate thickness has a higher connection strength. However, a statistical analysis using t-test shows that no statistically significant difference exists in the connection strength between these two different plate thicknesses. For recommendation, the following list can be conducted in the future to conduct an experiment using different type of self-drilling screw and focusing on other parameters such as different diameter, length of self-drilling screw, and type of screw head. To carry out finite element analysis for hybrid connection by evaluating a model of connection using finite element software.